Hello, my name is Yadvin, and today we are going to learn relations and functions, especially functions, not relations. We will discuss today functions. So, what is the definition of functions? Okay, so before coming to the mathematical definition of functions, uh, we are actually familiar with the word function. The word function. And we hear this in our day-to-day life, like some part of a machine is functioning or some part of a machine is not functioning, and the function of a machine is good, sometimes function of a machine is not good, right? So we know the word function. So basically, if we go in rough language, not in mathematical way, so it is like a machine which we will give some input and we are expecting some defined, well-defined output. We need unique output. Unique. Yes, this is not simply output, this is unique output. Like if we put some fruits in juicer, then we will get juice, right? So machine, that is juicer, we can say juicer as function, and the fruits are input and juice is output. So if we can draw a rough sketch of that. So this is juicer, and here we put input as fruits, and here we get output as juice. So this is our day-to-day life where we can relate, and like this, there are many incidents where we can relate this word function, right? So now we should come across the definition of a function, mathematical definition of function. Okay, so I am going to come on that. So again, so here we are going to define in some diagram format first. There are two sets. One set is A, another set is B, and there would be a mapping. So, and if we have a set A, so there are conditions on set A and set B as well. So it's they must have at least one element. They are non-empty sets. So cardinality of A, set A, is not equals to 0. And cardinality of set B is also not 0. So these are primary conditions. Even I will not write here, we will consider it, right? If set A is given, set B is given, they must have some elements, right? Okay. So here, how we define, okay, so functions will go like that. It's a map, and if would be written here like this. So it is actually, we are going to define every element of set A is uniquely related uniquely related to set B. Right? Such mappings are such mappings are called as functions. Called as functions. So basically, functions are mappings between two sets. So if consider all mappings are here, all mappings are here. So there would be some set of function inside it, right? So functions would be here. Yes. So this is how it looks. So all mappings are there, and some of the mappings are going to be functions, right? So consider how this mapping should be drawn. So this is going to this one. Consider this element is going to this one. This element is going to this one. This element is going to this one. This element is going to this one, and this element is going to this one. Consider like that. Okay, so let's name them 1, 2, 3, 4, 5, 6, and 10. Consider like that. And here 1, A, B, R, and 1 by 2. So I just want to, I just have written these numbers not in pattern here in set B, only to show that while choosing members of set B, which is our output set, there is no restriction. We can choose any elements, right? So it is a set B, any set, right? Likewise in A. So we can put here A at the place of 1. Does not matter. What matters is every element of A is uniquely related uh, to an element of set B, to an element of set B. Yes. So this is the correct and precise definition of functions, right? And whatever we have seen on previous page, these things, only to relate with this, that we have some idea from our day-to-day life, and then we proceed, right? So this is called a function, this mapping, right? So we can see that every element of set A is actually related to a single element. Yeah, better we can write a single element. That is also correct. So every element of A is related to unique element of set B, right? And in the set B, we can see all elements are not used, right? So, okay, so let's first define the terms. So set A is actually called as domain. Set A is actually domain. And set B is called as codomain. But we all must have heard of the word range. So what is range? Range is actually going to be all the elements which got used, right, in the set B. So, okay, so used element of set B, call it B prime. So that is going to be R, A, and 1. So this is our range. Right. And set B itself is codomain. So B is codomain. Codomain. And A is domain. So this is a definition of domain, codomain. And now we have a primary definition of function, and we have some idea what is function, right? Now moving next. Now while study functions, we need a background. Background means we need to relate with the things that we know, like we know a to the power x, e to the power x, 3 to the power x, 3x plus 2, 5x square minus 3x plus 2. These things. So we all know these two last things are polynomial. This one is polynomial, this one is polynomial, and these three first things are exponential functions, right? Okay, so now we are going to roughly learn whatever we know from the previous things, what are they are called, right? So we have one word, islet. So we will get some rough idea about whatever things we know. We are actually we have seen it previously, and how we will relate with them. So if we are given tan inverse x, so this is inverse trigonometric function. So first thing is inverse trigonometric functions. And L means logarithmic functions. Logarithmic functions, I am not writing the word functions. A means algebraic functions. And T means trigonometric functions. So trigonometric functions. Yes. And E means exponential functions. These all three. Exponential functions. So what we know previously, we are actually trying to relate with these things. So these are called as these things. I relates to inverse trigonometric function, L relates to logarithmic function, A algebraic function, T trigonometric function, and E exponential functions. Right. So this is approximate division. Why I am saying approximate? So there are many other functions which is mechanically defined. Mechanically defined means we have defined, right? Like GIF, greatest integer functions, fractional part function, greatest integer function means this one, right? And fractional part functions. So fractional part functions, and that is in curly bracket. So this is fractional part function. We all know fractional part function is bigger than equals to 0 and is smaller than 1. We will discuss it because we have to deal with this thing and this thing in detail. They are important elements of a function. So we are not going to ignore these things. So because I am here listing the things, so I am just introducing it. There is a greatest integer function and fractional part function. Okay, so now moving next. Next thing is types of function. See, this is also we can understand whatever functions are available. We can categorize in these 5 categories, right? But also the categories where we are going to categorize, that is most important and most famous. So we can categorize in the form like 1 1 and onto, right? And consider some function is not 1 1, so that would be many one. Many one and onto. And third type is 1 1, but not onto, so it is into. And fourth one is many one into. I have written these words 1 1 and onto, and many one and into, these four words. So what does mean by these words? Okay, so let's learn what does mean by these words. So consider here elements are A, B, C, and D. And in RHS, we have elements 1, 2, 3, and 4. So this is set B, this is set A. Set A is domain, right? And set B is codomain. Yes. So now we can see that if A is going to 1, B is going to 2, C is going to 4, and D is going to 3. We can see every element of A is uniquely related to B. And so this is function. And every element of A has some image, right? Okay, see here, one is image of A. So this side, if we are talking about one element and it is related to some element in codomain, so that is called as image. So one is image of A. And what we will call A? So A is pre-image of one. So these are two languages to talk about the relationship between A and 1. Okay, now what we should see that every element of A is uniquely related to B. So certainly this mapping is a function, right? Now we can see that any element of B which has some pre-image is actually related to single element of A, right? So this means 1 1. So this function is 1 1. This is how we decide 1 1. Okay, what will happen if there would be one thing extra? 5. This is a still 1 1. Okay, so there must be something. What if 5 would be there and if 5 would be not there? So that thing is called as onto. So if 5 is not there, then this is onto. And if 5 would be there, then it would become into. Okay, but why? So definition of onto is if all elements of B is got used, if all elements of B got used, it means the function is given function is onto function. And if at least one element of B which is left out, which has no pre-image, it means the given function is not onto, right? It is into, right? So here our given function is onto. Okay, so now let's try to understand what is into thing. So 1, 2, 3, 4, A, B, C, D. 1 is going to A, B is going to A, 3 is going to B, 4 is going to C. Now what is this function? This function now many one comes into light. See, 1 is going to A, 2 is also going to A. So is this function? Yes, of course it is function. Because 1 is related to only one element, 2 is also related to only one element, right? Yeah, of course A is related to two elements, but that does not matter, right? So whatever our input set is, means domain. So in domain, if multiple elements are going to relate to a single element, it is still a function. But from codomain, consider B has mapped to 3 and D is also mapped to 3, right? Now this is not a function. This is now not a function, right? Why? Because two element of set codomain is has same pre-image, right? So B has pre-image 3 and D has pre-image 3. Is this allowed in function? No, this is not allowed. So this is not satisfying the definition of a function. So if it is not function, how we are going to say it is 1, 1 onto or not? Of course not. If there would be function, then we will categorize into 4 category, and I have already listed those 4 categories here. 1, 1 onto, many one onto, 1, 1 into, and many one into. So coming here now, so if now I am making this function, so consider D is not related to 3 now. So whatever this function is, now it is function. This map is function. This is set A, this is set B. But which kind of function? Many one. Why many one? Because multiple element of set A is related to single element of set B. That's why it is what? It is many one, right? So many one, and one element is left out. So this is now not onto, not onto, not onto. Means what? If it is not onto, it's into. So it is into. So this is how we declare many one into, many one onto. What would be many one onto? So consider one more element 5 here, and 5 is related to D. Now here, all elements of set B has at least one pre-image, at least one. So it can be more. See, A has two pre-image, 1 and 2. That is fine, allowed, right? But at least there should be one pre-image. So D had not pre-image, but now we have written here 5. So it has now pre-image. So now it is not into. Now it becomes onto. So this is now onto. 1, 1, onto. So onto means if every element of set B is got used, that is onto. And if it is left out, that is into. At least one element has no image, no pre-image, sorry, no pre-image, then that mapping is going to be into mapping. And many one and one. That depends on these elements. If every element here is related to unique element of B, and that, see, first line is definition of function, unique element of B. It is still defining just functions. It is not saying anything about 1, 1. So what is 1, 1? If every element of B, which is related to some element of A, sum means that sum should be 1. Means if every element of B which has pre-image it must have only one pre-image. Or we can say no element of B, no element of B has multiple pre-image, multiple pre-image in A, then F is 1. This is definition of 1. And if it is not 1, 1, it is contrary, then it is going to be onto. So you can also understand like that. Not 1, 1 is equivalent to many 1. Sorry, many 1. Yes. And not onto is equivalent to into. Yes. So now this function is onto because every element of B got used. Got used means every element of B has at least, notice the word, I'm not saying one pre-image, at least one pre-image in set A. So it could be more, right? Then that is onto. So definition of onto is going to be every element of B has at least one pre-image, of, sorry, one pre-image in A. In A. See, notice one thing. We can remove the letter A and B, and at the place of A, we can write domain. And at the place of B, we can write codomain. Yes, keep in mind, codomain, not range, right? Codomain, yes. So that is it. So this is the definition of into. At least one pre-image in A, then F is onto, right? Here, every element got used, right? So that is onto. And if function is not onto, then that is into. So this is definition of onto, right? This is definition of onto. And if function is not onto, it is into. Means when we will call into, so that is now clear. If at least one element of set B is left out. So you should also notice one thing, that range is subset of codomain. Right? And if range is exactly equal, if range is equals to codomain, function is onto. This implies function, which is f, is onto. Because what is our range? Range is collection of all used elements. So we can also define range. So range is collection of, so I am going to define in words. So range is collection of all elements of codomain which has pre-image. Pre-image. That is range. So this is definition of range. So we have defined parameters and terms related to functions, and there are many more things will be coming to functions, right? So let's move to next. Polynomials are also one type of functions, but it comes in algebraic functions. Like we said, let, it is there, right? So let's try to understand onto things on graph. So if any rough sketch of function is given, like this, right? So this is function. Okay. So when we call a graph as function, all graphs are not functions. See, we are familiar of graph of the circle, but circle is not a function. Why? Because at 1x, x is always input. We will get multiple y, 2y. This is a 1y of this length and another y of this length, right? So 2y. That's why this is not a function. So this is called vertical line test. This is called vertical line test. As many vertical line you are going to draw, each and every time, your every vertical line is going to intersect function at maximum 1 point. It might be not intersecting, that is fine. If graph of our function is not existing at some point, so of course vertical line is not going to intersect our graph of function, right? So can graph of function be broken? Yes, it is allowed. Of course, it can be broken, right? Discontinuous, yes. Discontinuous means if your graph is like this, yes. This broken, so these two graphs are, both of them are broken. Yeah, but here it is jump, and here we have a gap, right? There are many points missing. So here if we draw a vertical line, this is certainly not going to cross our graph of function. So if we draw vertical lines, it is going to intersect the graph of function at maximum 1 point. So that is called vertical line test. Vertical line test. Vertical line test. And what this test gives us? So vertical line test gives us that given graph is function. Given graph is a function if and only if and only if it passes the vertical test. Passes the vertical line test. Then it is function. And if we check horizontal line test, and if we are getting intersected for at least one horizontal line at multiple point, then that function is going to be minimum function. right? So consider if y is equals to x cube is given, so its graph is going to be like this. Y is equals to x cube. So every horizontal line is going to intersect this line at only one point. So this function is 1, 1. This is graphical method to determine where function is 1, 1 or 1, 2. And consider y is equals to x square. So here at 1 y, we are getting multiple x. So this is actually many one function. And don't get confused with this thing. If we are given x is equals to y square, this is not a function. Not a function. Why? Because it failed vertical line test. And what was vertical line test? Vertical line test was that every vertical line is going to cut the graph at maximum one point. But here we can see that vertical lines are cutting our graph at 2 points, right? So at least this is happening in one case, it is sufficient to say that this is not the graph of a function, right? Okay, so that is because it failed vertical line test, so this is not a function. Like circle, graph of circle also fails vertical line test. See here, right? So this is not a graph of a function. Okay, so those who are not graph of the function is at least something, yeah, that is relation. So any graph is drawn which is relation at least, and some special relations are called as function. That's why I initially given the heading relations and functions. So without knowing relations, we cannot proceed functions, but today's topic was to focus on functions. Okay. So, and what is our horizontal line test is going to tell us that function is minimum or not. So we got here. And what is vertical line? So this is not testing into onto, right? Don't get confused. Sometimes we relate that this is testing 1, 1 and many one. So vertical line test is going to test into and onto, but it is not the case, right? Vertical line test simply says us the given graph is function or not. So vertical line test is for that, right? Okay. So vertical line test pass, it is a function. So what about this function? So this function is actually many one. See, one horizontal line is cutting at 2 point. So it's sufficient for one horizontal line test because there are many horizontal lines which is going to cut just at 1 point. So what we will call in this situation? Still in this situation, it is many one function. It is still many one functions, right? And what said the vertical line tests? These vertical lines. So vertical line test says it is a function, right? Okay. So which kind of function is going to be this? Log. So graph of logarithm is like this. So this is 1, 1, right? Okay, and here how we are going to define it is onto or not, because you can see I have discussed many 1, 1, 1, but I have not discussed onto. Okay, so that depends on the given codomain. So that's why there is coming something else term. So this is domain R and to R, right? So this is codomain, right? So if codomain equals to the range, what is range? So here we can see range is going to be entire y-axis because every y there is x. We can go from here and we can see there is some x existing. right? So on y-axis, everywhere this curve is existing, this curve, this is our function curve. So this is actually y is equals to f of x, and here our f of x is ln x, right? This is logarithmic function. This point is 1, 0, right? Okay, so in this scenario, if our, see, this is given codomain and our range is going to be what? Our range is going to be also R, because this graph is existing throughout the y-axis. So this is actually 1, 1 and on 2. Okay, consider e to the power x, and definition is given like this. So in this e to the power x, we can see our graph is going to be like this, right? So here we can see domain is R, but range is 0 to plus infinity, right? In negative side, our function is not existing below the x-axis. So what is this function is going to be? Into. For every time we will draw horizontal line, we will get only one intersection. So this is 1, 1. So 1, 1 into 1, 1 into e to the power x, 2 to the power x, 5 to the power x, 1 by 2 to the power x. So all of these are here 1, 1 into. But this into can be onto as well. But when? So when here our function is written like this. From real number to going, it is r plus. Positive reals, that is fine, or r plus also can be written as 0 to infinity. So our function may be defined in this manner. So now this is onto and 1, 1, right, for these functions. Why onto? Because here range is equivalent to codomain. And what is codomain? This is codomain. And what is domain? This is domain. Right? Okay. So this is how we have progressed today. So we will continue tomorrow. I hope this is helpful. Thank you.